So in this lesson, we are going to be solving multi-step equations. All of the equations that we deal with in Unit 1 are one variable equations. And I have 6 examples that we're going to go through today of a variety of different types of equations you could potentially see. So the first one we're going to look at is 11x minus 4 equals 29. So my goal is to get, let me grab another cover. My goal is to get x by itself. I want x equals a number. So we're going to use inverse operations to go step by step to start to move things away from x. For now, I'm going to ask you to show your thinking along the way of what you're doing. And at some point, you might get to a point where you're comfortable enough that you won't have to show every single step, and you might be able to do a little bit of it in your head. But for right now, I do ask that you are showing me all your work when you're doing, when you're doing these practice activities. So the first thing that's in my way is this -4. So I'm going to add 4 to both sides, because what I'm doing is I'm going to create here with these two -4 and the +4, that's going to become 0. So there's not going to be anything there anymore, and I'll be left with just 11x. And then 29 plus 4 is going to give me 33. And all of these examples in this lesson are perfect examples of what could be on the calculator inactive section. Well, that made it worse, didn't it? That's better. So again, still trying to get x by itself. Right now, 11 is being multiplied by x. So I need to divide, and 11 divided by 11 is going to leave me with 1. So I'd be left with just plain x. And then 33 divided by 11 is 3. So that would be my answer. Now, if I wanted to double check and make sure that I got the correct answer, I could take 3 and substitute it back into my original equation and check and see if it in fact does give me 29. Well, 11 times 3 is 33 minus 4, and 33 minus 4 does give me 29. So that tracks. I got the right answer. We're good to go. The next example we're going to look at has a fraction, the dreaded fractions. So right now, all of this n plus 1, both of those terms, are sitting in the numerator. Until the denominator is gone, I can't touch anything that's going on up here. -2 does not simplify with either of these terms, so I have to leave it in the denominator. And in order to create a denominator of 1, I would have to multiply by the same thing in the numerator. So here's what's really happening. Currently, I have some stuff, so I have n plus 1 divided by -2. When I multiply that by -2 over 1, what this is really telling us is I have this thing, n plus 1, and I'm going to multiply it by -2, and then it's also going to be divided by -2. And we know if I'm multiplying and dividing by the exact same number, that leaves me with 1. So I would be left with just n plus 1. So nothing about n plus 1 is actually changing because of what's happening right here. But because I multiplied by -2 on the left, I also have to multiply by -2 on the right. Equations are like a perfectly balanced scale. And if I don't do the exact same thing to both sides, that scale is not going to be well balanced anymore. And I have to maintain the equality or the balance in my equation. Otherwise, I'm not dealing with the same equation that I had at the beginning. So, multiplying both sides by -2, our denominator is now gone because it's become 1. So I'll be left with n plus 1 equaling 15 times positive 2 would be 30, so 15 times -2 would be -30. And then I'm going to subtract 1 because I'm doing the opposite. Oh, sorry, I was doing my steps in pink. -1, -1. So I'll have n being equal to, now I'm at -30, I'm going more negative, so that would be -31. Our next equation also has a fraction in it. So my goal is to solve for c. And the first thing I need to do is get this 7 over to the other side. So I'm going to do +7 and +7. Maintain that balance or that equality of my equation. 65 plus 7 gives me 72. And then these two 7s are going to create 0. So that'll be 3/4 times, technically there's a times here, times c. Now I'm going to show you 2 different ways to go about this. One option is you can take this fraction and pull it apart step by step. So the first thing I need to undo is the denominator, which means I'm going to multiply by 4 on both sides. Now, if I'm doing this without a calculator, in my mind, personally, if I had to do 72 times 4, I'm going to break it down so it's not so much work. And I'm going to do 70 times 4, and I'm going to do 2 times 4, and I'm going to add those two things together. Well, 7 times 4 is 28, so 70 times 4 would be 280, and then 2 times 4 is going to give me 8. So that would be 288 over here. And then on this side, I'm going to be left with 3c. And then I need to divide by 3. Now you can go about this long division in a lot of different ways. Personally, for my mind, I like to break it down into things that I'm more comfortable with, and I kind of work backwards using multiplication. So I know that I could evenly divide 240 by 3. So that would be 80. Now from 240 to 288, I'm missing 48. And I can evenly divide that by 3, and that's 16 3 times. So, and we'll have lots of practice with this. I do not like long division personally, so I kind of break it down for my brain. These two things added together give me that 288 that I started with. These two things give me 96. So that tells me 288 divided by 3 is 96. So, like I said, this step right here, I'm going to show you two different ways to go about dealing with that fraction. If this worked for your brain and you're good with it and you know you'll never forget that way, go with it. If not, if you think that that's too much work, I'm going to give you another option. Now this one, you got to really pull up your bootstraps, but I'm going to show you both ways. Now here you'll notice I did the opposite of each of these things one step at a time. I multiplied by 4 to get rid of my denominator, and I divided by 3 to get rid of that numerator. It is possible to do both of those things at one time, and what you're doing is multiplying by the reciprocal or the fraction inverted. Now what happens if I have 4 over 3 times 3 over 4? Well, 4 times 3 is 12, 3 times 4 is 12. That gives me 1. I have the same things in the numerator and in the denominator. It's going to become 1. So I can do that at once. So this part over here would leave me with C. And then for this here, I can break it down however I want. I can do 72 times 4 and then divide by 3. Or I can see that 72 is evenly divisible by 3. If you don't know that off the top of your head, it's totally fine. This is really close to 75, and 75 divided by 3 would be 25. So I would really quickly run through in my head, well, this is 3 less than that. I'm dividing by 3. So that tells me in my 3 groups of 25, I took 1 off of each of those groups of 25. So 72 divided by 3 would be 24. And then the only thing I haven't done was multiply by 4, which again still gives you 96. Because I would do 20 times 4, and I would do 4 times 4. Well, 20 times 4 gives me 80. 4 times 4 gives me 16, and that gives me 96. So either way you slice it or dice it, this step right here, you could go one of two ways. You still get 96 on both sides. Most people tend to be more comfortable with the first way I did this, but I'm giving you both options because I don't care how you do it, as long as you understand each step along the way. All right, so that was long-winded. I'm going to make this one not so long-winded. So here's our next example, 2b divided by 3 plus 6 being equal to 24. Now with this one, you could rewrite it so it was 2/3 b if you wanted it to look like our last example, but you don't have to. I'm going to start with my inverse operations by subtracting 6 from both sides. This is going to give me 2b divided by 3 being equal to 18. I'm going to multiply by 3. Three 18s. If you don't know that off the top of your head, totally fine. I would do 10 times 3 and I would do 8 times 3, and I would add them together. This is 30, This is 24. Adding them together gives me 54. And then 54 divided by 2. So if you don't know that off the top of your head, again, totally fine. 50 divided by 2 is 25. 4 divided by 2 is 2. Adding those together is 27. So 54 divided by 2 is 27. Now, if you did rewrite this as 2/3 b plus 6 equals 24, it would be exactly like the last problem we did. You would also be able to multiply by the reciprocal. It would be absolutely fine. It would not change your answer in any way, shape, or form. You would still end up getting 27. And I have 2 more examples for you here. Now, in this case, we have parentheses. Parentheses to us represent multiplication. It means the thing on the outside is being multiplied by both of the things on the inside. So I'm going to take 6 and I'm going to multiply it to 5m, and I'm going to multiply it to -3. So 6 times 5 gives me 30. So I'll have 30m. 6 times -3 gives me -18. Now I need to distribute. I'm multiplying by 1/3, which is the same as dividing by 3. So 24 divided by 3 is 8. 12 divided by 3 is 4. So now I have variables on both sides and I have constants on both sides. Constants are a number that does not have a variable attached to it. So I look for the side of my equation that has more of the variable. Here I have 30, here I have 8. So my goal is going to be to keep m on this side and move the numbers to the other side. So I'm going to start and I'm going to subtract 8m. So 30 minus 8 leaves me with 22m minus 18 being equal to 4. And then I'm going to add 18 to both sides. And that's going to leave me with 22m being equal to 22. I should be able to see at this point the only thing m could be is 1, but just in case, dividing both sides by 22 leaves me with m only being equal to 1. Now if I went back and I double checked, again, just to prove that you could, I would have 6 times 5 times 1 minus 3. And my goal is to see, is that the same as 1/3 of 24 times 1 plus 12? Well, let's see. 5 times 1 is 5, minus 3 is 2. So 6 times 2, which gives me 12. And then I've got 1/3 of 24 times 1, which is 24, plus 12 makes 36. So I'm doing 36 divided by 3, which is also 12, so it checks. Last but not least, I have another one where I'm dealing with parentheses. So I'm going to do that multiplication first. So the 8s minus 10 is not going to change at this point. 6 times 3 is 18. 3 times negative 2s gives me negative 6s. And now I'm going to look and see where I have more of my variable. So I have positive 8 on this side, negative 6 on this side. That tells me I want to get this 6s over to the other side because I would rather deal with positive numbers for my variables. So 8 and 6 added together gives me 14s. The minus 10 and the 18 are going to stay as they were. I'm going to add 10 to both sides. We'll have 14s being equal to 28. And then dividing by 14 tells me that my value of s would have to be 2.